Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's main meeting. Doing a quick shift at the end. Unfortunately, there's a little mix-up with the speaker, so I'll instead do a talk that is kind of similar to the one that was on the agenda. This one is specifically about saving money while working in cloud services like in Azure or in AWS. If that doesn't sound like an appealing topic, my apologies. We had a little bit of a mix-up, but hopefully you'll stick around. We'll talk a little cloud and have a good evening. So my name is Kevin Feasel. I run the Triangle Area SQL Server Users Group. You probably hear me on a regular basis at these meetings, but also I'm a data platform MVP out of Durham. I have independent consultancy, Catalyxy Services, where I do independent consulting, and Curated SQL, which is every day I try to find and link to 5 to 10 interesting posts on topics all across the data platform space. So that's curatedsql.com. As a quick note, I have chat right in front of me here, so if you have any questions that come up throughout this, let me know, and I'm happy to take them at any point in time. So I'm going to get a slightly smaller picture of me on screen here, so that way you can read the text. But what we're going to talk about is a little bit of the cloud pricing model. So I'm going to use Azure as the topic. And Elaine, yes, unfortunately, a little mix up with our speaker. Couldn't get everything sorted out, and so I had to pivot at the last moment. So we won't be talking migration to the cloud. We'll be talking money saving in the cloud, as I don't have a topic on cloud migration that I could spin off the top of my head, unfortunately. So we will be talking about cloud pricing models. We'll be talking about what this all means and how things work, get an idea of service costs, ways to save money in the cloud, and talk about it with respect to a reference architecture. You know what, Elaine? I'll give you twice your money back. That's just the kind of guy I am. So this is a companion talk to a prior session, and let me copy this link and paste it in chat if you're interested. If you're brand new to the idea of the cloud, this is a talk that is more of an introductory level session that gives you an idea of cloud terminology. So I'm not necessarily going to explain a lot of cloud terms unless people ask in chat, in which case, yeah, I'll wing it. But I do expect some level of familiarity with cloud concepts, and then we'll talk about how we can use some of those concepts and save a bit of scratch along the way. So I've got a few topics for tonight. The first one is how we do pricing. Then we figure out, based off of pricing, how much my stuff will actually cost, and we'll go from there. Cloud providers usually have a pay-per-use model, and we get billed monthly as a result. Now, a lot of people start off their cloud journey with rented virtual machines. So I'm taking some virtual machines that I have on premises, I'm moving them into Azure or into AWS, and I rent those by the month. But then, as you get a little bit more mature, you gain a bit of an idea of how these different services work together. We see companies move to platform as a service offerings or serverless or functional applications. And a joke that is less of a joke than it was a decade ago is basically the cloud today is essentially like a mainframe from the 70s, where you're basically getting billed for microseconds of CPU utilization. And the way to save money is minimize how many microseconds of CPU utilization you need. Minimize the amount of pie that you're taking of that CPU pie. So our billing model. Typically, cloud services use an operating expenditures billing model. And on-premises hosting usually is more of a capital expenditures model. So let's talk about what the difference is between those two. And I'm actually going to hide myself for a moment because there's a lot on this table. So I won't read off everything from the table, but basically capital expenditures, operating expenditures. And my wife is the CPA. She's downstairs, but she can't hear me, so she won't be able to correct me on any of this. Capital expenditures are usually about buying fixed assets. They're buying buildings, buying plants, large equipment, things that you expect to keep for a large amount of time, for a long time, multiple tax years. So that's the important thing. It has to cover multiple years. So you can't have a capital expenditure that you pay for entirely within one tax year. What you can do with capital expenditures is either depreciate or amortize the cost of the capital expenditure, where the idea is you define a useful life for the equipment. So let's say you have a building that you expect to last for 50 years, 50 years. And in that case, you can draw up a schedule that says the easiest schedule would be every year we're going to depreciate this by 2%. So over the course of 50 years, you're depreciating your asset, which has certain tax implications. What this means is I may have spent a large amount of money in year one, but I'm not going to pay all that tax on purchases. I'm going to push it out to future years and have a smoother tax schedule. So that way my accountants don't have large, lumpy tax bills. Budgeting for capital expenditures, though, takes a lot of negotiation, takes a lot of long-term planning. This is one of the reasons why IT directors and IT staff hate capital expenditures, because you have to fight with the CFO, you have to fight with the accounting team, you have to make your case, help people understand how much it's going to cost, you have to plan it out, budget it out. Oh, your servers, well, they're going to last for 5 years, so you'd better buy 5 years worth of servers, and if you mess it up, if you underestimate, you're in a problem. Now, I'll save the last line for the end. Let's talk a little bit about operating expenditures, because when you talk to the salespeople at any cloud provider, at Google, at Amazon, at Microsoft, they will push you hard on OpEx because, it's so easy. Operating expenditures, you usually have managers who can support OpEx, because the intent of this is daily operating expenses. This is, I need to buy a ream of paper. I need to buy a box of pencils. I need to buy some small item, a chair. And I don't want to have to go through the capital expenditure process to buy a ream of paper. I just want to go down to the office supply store, pick up a ream of paper, and come back because we need to get stuff done. So this is day-to-day expenses, things that fit within one tax year. CapEx, multi-year, OpEx, single year. What this means is you cannot amortize or depreciate for OpEx. So this is something that limits your ability to change the tax schedule. But it is easier for a single decision maker to budget. Usually, OpEx amounts are small relative to CapEx. And this last item, EBITDA. EBITDA is earnings before interest, depreciation, taxation, and amortization. EBITDA is basically what companies use when they're not profitable and they want to have some measure that makes it look like they're profitable. So EBITDA is a fancy way of saying, well, it's not profit because we're taking out all these things from the bad side, the expenditure side. But, if you take out all those things, we look pretty good. And the general idea is, I'm making a little bit of a joke out of that, but the general idea is that if you are a relatively new company, maybe you've just IPO'd, you're relatively young, that you're going to have a lot of expenditures around growth, around capital expenditures, or things that are intended to help the company grow. And EBITDA is a measure that's intended to not penalize those types of expenses, whereas it will penalize your day-to-day expenditures because that's stuff that the expectation is it's not helping you grow. So CapEx, there is no negative impact on EBITDA because you can depreciate, you can amortize. So if you buy a very large piece of equipment, you can strike that off of EBITDA. You subtract that amount from the expenses category, and you report that, yeah, you just had no additional expenses. Whereas if you spent the same amount of money on operating expenditures, that will hurt your EBITDA. And companies and markets are looking very heavily at EBITDA versus profit, which means that by spending all of your money in the cloud using OpEx practices, you may actually be harming your company's ability to get additional funding, get additional lending, or get additional shareholders in the future. Which seems a little weird, especially because the sales pitch is OpEx is so much superior to CapEx. It's so much easier, better, and nicer, and everyone loves it. Turns out that, yeah, there is a downside to OpEx. So, all right, summarizing this. CapEx is harder to push through, can be more of a risk, especially if you're considering that I have to buy these servers to last X number of years, 3 years, 5 years, whatever. So it's fixed expenditures, but you have the benefit that for something like EBITDA, yeah, I don't have to worry so much. OpEx is easier for a single business decision maker to approve, and you can get more flexible spending, but it does count against EBITDA. So keep that in mind. OpEx is not in every case superior to CapEx. There are benefits, there are costs to both of those. Speaking of costs, when we're talking cloud providers, everything's got a cost, except data ingress. Data ingress is free. It's like Hotel California. You can put in as much as you want, but it can never come back out, because as soon as you want to egress, yeah, you got to pay for that. Oh, you actually want to store the data? You're not just sending us the data to like throw it away? Okay, well, you got to pay for that. If you want to use compute, you want to like do anything with the data, pay for that. If you want to use their networks within a network, within a region in Azure or AWS, that's free. But you're crossing regions, that's going to cost you. You're taking stuff out of a region, that's going to cost you. You want high availability. You actually want this thing to be available throughout the entire day. And even if something does fail, that'll cost you extra. If you want faster performance, we've got this nice little slider where you can move it and pay more, and then you might get better performance. And are you running this in dev or test environments? You're still paying. Doesn't matter if it's dev or test, you're still paying. Now, some services are free. Some services do have free tiers. And no, I gotta get it like this. I don't know. I'm bad at reflection. I suppose if I did something the other way around, maybe I could point my finger at the pay with an asterisk. Basically, that is the one thing that is maybe going to be cheaper. So we'll talk about that later. So next up, how much will this actually cost me? And there is a pricing calculator. Azure has one, AWS has one. The Azure pricing calculator is pretty useful. It can be confusing. There is usually a lot of detail on it, and sometimes that detail is unnecessary. There are some services where they'll have you fill in dozens of items, but most of these items don't really impact the price. But they do affect exactly how much Microsoft is going to charge you. So if you know the exact answers to all the questions that they ask, then you'll be able to get pretty much down to the penny how much they're going to charge you for a month. But if you're just trying to wing an estimate, you're trying to like say, hey, give it to me within a big round number, then that pricing calculator can be a little too difficult. So I still recommend check out the pricing calculator, try it out, learn it, because if you are using Azure, this is the best way to understand how much things will cost. The way that the pricing calculator works is you go to the site and there's a nice little search menu. That nice little search menu allows you to search for products. So we can type in the name of a service, like if you want the Azure OpenAI service or Azure Synapse Analytics, something like that, a virtual machine. Then you can add it to the calculator. once you've selected your option, in this case, I'm saying Azure SQL Database. So you can navigate in the left-hand bar or type in the product name. You can select the chiclet for that particular product, and that brings you into a screen where you get to fill in quite a few details. Now, the way that it shakes out is that even within something like Azure SQL Database, there are a variety of options that are available to you. Do you want a single database or part of an elastic pool? Do you want a vCore model or the old DTU model? For service tier, do you want it to be business critical or general purpose? The hardware series, do you want more memory or more storage or more CPU? What's the relative loadout that you want? And how many vCores if you're in a vCore model, or what DTU level if you're in the DTU model? Also, don't discount region. It turns out that different services have different prices in different regions. And you may find that an Azure SQL database in West US could be more expensive than one in East US 2 or North Central US. Or say a newer region, let's say Sweden Central, might have cheaper Azure SQL database prices than the regions that you're normally used to dealing with. So if you're really looking to minimize those dollars spent on a service, you do want to check out the relative prices of different regions. And the easiest way to do that, there aren't that many easy ways to do it. There are a couple of websites that will help you track the prices in different regions. There are ways that you can get the prices, I recall, from the AZCLI, the Azure command line, and you can try it out in different spots and see what those prices look like. But that will potentially save you a little bit. We're not talking enormous amounts of difference in terms of pricing, but maybe 5% price difference, which if we look at this number that's $20-some thousand a month, let's see if I can kind of point right there. There we go. I learned how to reverse directions. Where it's like $21,000 a month, if I said I could save 5% by choosing a different region, that might make sense. So we wanted to show you the bottom number. We have the ability to look at what is that number, what is the estimation, and then there is, of course, the first option that every business person is ever going to ask about. How do I get this number into Excel? And that's the first button that is there because Microsoft realized that's going to be the first question everybody asks. So we can export it to Excel and it creates a fairly decent spreadsheet for us. We can save this and come back to it later and even share out a direct link. So I could send you a link to the pricing calculator. You could make some changes and maybe share it back with me. It's a tool that's worth learning. It's reasonably useful, even if it is a little complex. I think it's worthwhile to know. But it does not have every Microsoft service. So if you're talking about Power Platform, Power Apps or Power BI, if you're talking Microsoft Fabric, if you're talking M365, all of this stuff outside the scope of the pricing calculator. The pricing calculator is specifically for Azure services. So for Microsoft Fabric, you would need to track that pricing separately. Also, for any item that is in a private or a public preview, you will not be able to see it in the pricing calculator. When services are near GA, they eventually announce, hey, here's what the pricing schedule is going to look like when we go GA. While they're in preview, you don't have to pay for them. Once they become generally available, then you have to pay for them. And usually about a month or so before they become GA, there's a blog post that gets released that says, this is how much things are going to cost. You might even see it on the sales page for a product that, this new service, let's say when Azure Synapse Analytics was public preview and becoming GA, they had a blog post that indicated this is how much it's going to cost for different things. And you could look at the sales page for Azure Synapse Analytics and see, here's the pricing. But if you went to the pricing calculator, Synapse would not be there. It's not until it goes GA that it's actually in the pricing calculator. So that's another thing to keep in mind as you're planning out how much things will cost. So the next question comes up. Is it actually cheaper to have something in Azure or in AWS than to be on premises? The answer is it does depend. And for this, I'm going to move my camera up to the top so that you can see. And now I have a disembodied chest. But, that's okay. It happens to the best of us. So, all right. If your data center is really expensive, the public cloud may be cheaper. If we're talking about a data center that is, they'd have to be really expensive, but there are examples of this. If you have some extreme hardware requirements, no, you probably are not going to save money in the cloud, and they may not even have the appropriate offering. So if like, for example, you're running entirely on all-flash arrays, you need extreme storage requirements, or direct attached NVMe for everything. You have hundreds of CPU cores. Maybe you have like a 256 CPU core box, and you've got dozens of these boxes, and they're all running direct attached NVMe. Then, yeah, you're going to spend a whole lot more money in Azure or in AWS trying to spin up something that is anywhere near that level of performance, and it may be as much as an order of magnitude larger in terms of cost. So for those cases, probably not worth it. If you're just doing a lift and shift, if you're taking VMs that are on premises, you're moving them into AWS or into Azure, it is definitely more expensive. There are benefits that you're getting by moving to Azure. You get some things like, say, I have the ability to fail this over very easily. I can have availability zones where if one data center fails, the next data center just picks up the load. I have the ability to power off and power on these machines and save money if I'm not running them. That's something we typically don't have with a data center, because the data center is there are some variable costs with the data center, but usually the big chunk of change for a data center is fixed cost of how much it is to get space in the data center. If you've got your data in multiple geographic regions, it can be cheaper in a public cloud than hosting in several data centers using several data center services. But I will say, even if it is cheaper, it does take some time and effort for you to translate what works well on premises, what works well when everything is co-located in the same building, versus when you have resources that may be spread out across a country or multiple countries. It also takes some time and effort to understand that networks fail, networks can be slow, networks can be laggy, that when storage is further away from compute physically, things do slow down. And so you have to rethink some of the application patterns in order to adjust to that. So important things to keep in mind along the way. Now, every month, somebody at the company will get a bill from Azure. If you're watching this, you're probably not that person. However, you might know who that person is. It's maybe your C-level, your VP of engineering, your CFO might receive it. Someone up the chain is going to have this bill, but you might have the ability to view billing information as well. So there's a section in the Azure portal at the very bottom called Cost Management and Billing. That blade will give you some ability to drill into what is in that monthly bill. So this is an example. This is actually my monthly bill for my Visual Studio account. So I get a $150 credit per month, and we can see some of the things that I spend it on. Like I've got $74 in this month on DTUs for cheap SQL Server, Azure SQL databases. So we can see the breakout. Basically, it's telling us what service it is, the specifics of that service, and with resource, sometimes it'll get into the details. Note that it doesn't tell me which database names, which Azure SQL databases are S0. So I have to figure that out myself. There are units consumed and billable units, and then the rate, the billing rate for them, and the value is how much I'm paying. In this case, it's US dollars. So I can look across, understand what the pieces of the bill are, figure out what are the most expensive parts of my bill. The SQL databases are probably about, 60% of my total bill, because I think I use about $130 of those credits each month. So more than half of that is the SQL databases. And, for the rest of it, I've got a few things that are running, but not a whole lot. If you go into cost management, then there are a couple of other things that we can look at. So checking out the screen, the second item up there is report on and analyze trends, and the third item is control and optimize costs. Both of those are actually really good tools that are available for you. Now you have to go in and learn about them or talk to a cloud solution architect or someone to point you in the right direction. But if you drill into, say, the cost analysis, what it's going to give you is a little bit more information. So in this case, I'm looking at CS Training Wide World Importers DW. And this is one of my S0 databases. It cost me $14.44 for the month of September. And I can see those other databases. So I have 5 databases here that are each costing me $14.44 a month. And I can ask, hey, wait, what is this database? Why is it there? Do I still need this thing? And if I don't need it, I can turn it off or get rid of it. So this is an important part of the analysis that we would want to look at. We want to dig into what exactly are the things that are costing money, because I might find out that, I can do this to reduce network bandwidth utilization by 10%. And then I look at the budget and say, network bandwidth costs $3 this month. So I saved us 30 cents. Maybe not a great use of time. Whereas if I'm able to scale down one SQL database, I might save thousands of dollars a month, depending on how big that puppy is. So the cost advisor can provide automatic recommendations. In my case, I don't have any because I don't really have many services that are expensive on this account. However, in your environment, I would recommend checking that out. So in cost management, the cost management section, there is an advisor recommendations option. Check that option, and we have our answers. We have potentially, here is what you can do to save some money. Like, this VM is oversized. This VM is in an older class and the newer class is actually less expensive, or something like that. So now let's talk about actually saving some money. So we got an idea of how we figure out how much things cost, but all right, how do we save cash? And again, if you have any questions, drop them in chat along the way. One of the major things that the CSA crowd will push is reserve capacity. And reserve capacity is actually a pretty good way of trading your commitment for a discount. So Azure has 3 separate models for pricing. Number 1 is pay-as-you-go, or pay-go. The second one is a 1-year reservation. The third one is a 3-year reservation. So generally, a 1-year reservation saves you about 30 to 40% off of the pay-go price. A 3-year reservation can save you 50 to 70% off of that pay-as-you-go pricing. And that leads to a pretty good question, which is, why would I ever use anything other than 3-year reservations? So I want to talk about that. Number 1, you want to choose pay-as-you-go if you don't use the service very often. If the service is only up 10% of the time, let's say it's a month-end calculations process and you need to start up the VM, run the month-end calculation. It takes 3 days to run, and then you turn the thing off. Well, in that case, if you're doing reserve capacity, you're actually paying for 100% utilization for the month. So that's the starting point. Basically, they say, if it's going to cost you $1,000 to have this virtual machine run for an entire month, we'll save you 30%, so you'll pay $700. Or we'll save you 50%, so you pay $500. But if you're only running it 10% of the time, you're only paying $100. So if you're just trying out a service, or if you're not using a service at least 30% of the clock time, choose pay-as-you-go. A 3-year reservation is if you want to have a service used 100% of the time, and you're willing to make a 3-year commitment, then go with that. Also, something that has been kind of interesting, the accounting world is a little slow, but they have been shifting some items to be capitalizable in the cloud. I'm not an accountant, obviously. My wife is not here to yell at me, so I can't. So, take this with 4 grains of salt. Exactly 4 grains of salt. No more, no fewer. But there are certain items that you can capitalize. You can capitalize the licensing costs of Windows or of SQL Server running in a cloud. I got to think about that. No, sorry, you cannot. That's the thing you cannot capitalize. You can capitalize the physical equipment that is used over a 3-year period, but you can't capitalize the licensing fees. So there are some things that you can capitalize, some things that you cannot capitalize. Check with an accountant. Things changed about 2018, and I think there were some minor changes since then. So if you have a 3-year commitment, you can potentially amortize some of the costs. 1-year reservation is you use a service near 100% of the time, but you're not willing to make that 3-year commitment. But again, kind of ask the question, why would I want a 1-year reservation if I need to use the service 100% of the time? Why not just use that 3-year commitment? Well, there is a specific use case, and I took it off the slides here for time, but there's a specific use case, and that specific use case is if the prices of services are dropping considerably, then it may make sense to have a series of 1-year reservations. A classic example of this, there was a stretch for about 5 years where every year virtual machines would drop in price. And what would happen is by the time your 3-year commitment was through, you would actually pay more than a person who made 1-year commitments, 3 separate 1-year commitments, because the price of VMs was dropping that much during this time frame. This is no longer true, so it's certainly something that if you're going to try this strategy, make sure that the math checks out before you do it. But there have been times historically when some services are better priced in a series of 1-year commitments versus that 3-year commitment. Now, this was also before the time when you could amortize those expenditures. And so that kind of nudges more in the direction of a 3-year reservation, that you're able to amortize expenses a little bit more and kind of makes it a slightly better use case or argument for the accounting team than the series of 1-year reservations. So you're trading some flexibility for a good amount of savings and the possibility to shift tax burdens around over a 3-year time frame. There is also this notion of hybrid benefit. So the idea is you can use on-prem licensed versions of some software in Azure. Your Windows licenses, your SQL Server licenses, your Red Hat licenses, SUSE Linux licenses. If we're talking SQL Server in particular, you can use hybrid benefit, and it will allow you to migrate to an Azure VM as infrastructure as a service, or to Azure SQL Database, or to Azure SQL Managed Instance. The trick is you can't use the same license both on premises and in the cloud. So if you have, say, 20 vCores of licensing or 20 cores of licensing for SQL Server, you can apply those to a VM in Azure, and for 180 days, there is this concurrent use right. And the concurrent use right says you have 20 cores, you've already applied them to a server on premises. You can also apply those to a server in Azure under the notion that you're going to migrate from on-prem to Azure. So you kind of have that dual use for 180 days. After 180 days, your migration has to be done, or you shut off that Azure VM and you don't do it again. So there is that grace period for concurrent use, but it's a 6-month period. Get your migration done, and you can switch over. And now you're licenses that you bought on premises apply to your hardware in Azure. I had an asterisk earlier about dev test, and for development and testing workloads in particular, you can create something called a dev test subscription. It's part of your Visual Studio subscription, and it allows you to use dev and test pricing, where that removes licensing costs. So what that does is, if you have a Windows virtual machine, right now, if you just use a normal subscription in Azure, even if you call that subscription dev subscription or test subscription, you're paying full prices for everything. So Azure doesn't care what your subscription name is. You're paying production prices. You're paying full licensing costs on everything. And that means when you spin up a Windows VM, you are paying, if you don't have hybrid benefit, you are paying for that Windows license and for the virtual machine compute and for the networking and storage and etc. If you have an Ubuntu Linux VM or a CentOS VM, you're not paying for licensing, so it is a cheaper VM. Well, if you're using dev test pricing, those licensing costs go away, which makes your Windows VM the same price as your Ubuntu VM. It removes the licensing cost from Azure SQL Database, and it'll provide some discounts for other platform as a service offerings. Now, the kicker is you can only use it for dev and test environments. You cannot use it for production. So, hence the name Dev Test Subscriptions. In addition to this, there are also some products that have either a free tier or a low-cost development tier. For example, IoT Hub. Dev Test, doesn't every developer need a Visual Studio license too? I believe the answer is yes. But yeah, at a company like that, you would expect that the developers already have those licenses. So I think that's the how they make up some of the cost of dev test subscriptions. But if you do the math on it, most likely the developers already have those licenses, and so you've already eaten that cost. If not, then maybe worth doing the math on it. But once you have a few SQL Server instances, one or two SQL Server instances in dev, that's probably already, the licensing for that is already paying for your developers to get Visual Studio licenses. That's the way I like to think of it, at least. So, IoT Hub. I have an example here where there's a free tier that allows you to send 8,000 messages per day. 8,000 is not a lot. It's, if you think about, I'm going to send one message every second. Well, over the course of an hour, you're sending 3,600 messages. Over the course of 3 hours, you've already hit your limits. But it is enough for you to try things out. For a development environment where you're just trying to get things working, this is enough to go by. So that might work in your dev environment. Maybe in a testing or a staging or a production environment, you would have something that is not the free tier. But there typically are significant price differences between the premium tier and standard tiers. And for a lot of services, the key differences between premium and standard is not so much in terms of development surface area, things that you're allowed to do in one but can't do in the other. Instead, it tends to be around high availability. What's the service level agreement? What are some of the quality of life niceties that get thrown in on premium? There are exceptions. Azure API management is an exception to this. There are some things that are important for API management that you really can't get outside of premium tier. So that may be a case where it's a tough sell. But they have a development tier, which is, if I remember right, very similar to premium tier in terms of what you're allowed to do with it. Just you're not allowed to use it in production. So that's even with my counterexample, there's a caveat to the counterexample. So pay attention to those tiers. For lower environments, I do recommend standard tier or developer tier or free tier. For production, I am going to push people toward premium tier. There may be reasons why you don't need premium tier, and in which case, cool, go for it. It'll save you money. But usually there are high availability concerns or service level agreement concerns that just make it not viable to have a production grade quality process while using standard tier components. That includes SQL databases. So if you're using SQL Server in a VM, premium storage, premium CPU support, I would not want to try to run a production level VM in cheap HDD, hard disk level quality of drives. That is painful. I would not want that. Scaling down. This is one of those things that you will get a lot of recommendation from the CSA crowd, the Cloud Solution Architect crowd, that, hey, you can scale up and scale down. And this was one of the sales points of cloud services a decade ago. The idea is, well, when you need your workload, you can just scale it up. And when you no longer need that heavy workload, you can scale it down. And if your company is predictably dependent, like these 5 days of the year are 80% of our traffic because, we're like, this is the website for some big race or the Super Bowl or something, where for most of the year we don't get a lot of traffic, but 5 days we absolutely need to be built for business. In that scenario, yes, you can definitely plan your scale up and plan your scale down and probably save a lot of money versus buying the hardware level sufficient for your maximum load. For dev environments or 9-to-5 scenarios, you probably have some way of scaling that down. You might turn off dev services overnight while the developers are asleep. And if most of your traffic is happening in a small stretch during the day, maybe you can get away with this. At an extreme, there may be cases where, everybody's gone home, so let's turn off the SQL dedicated SQL pools in Azure Synapse Analytics and reduce costs in off hours by a lot. But what I've experienced mostly is this is not practical. Unfortunately, in most cases, we're talking about, no, the server's got to be up 24/7. Maybe we can scale it down overnight, but overnight we're still running processes. We're running those batch jobs that we couldn't do during the day. Also, I don't think scaling down actually works as well as the sales pitch says, because scale down takes time. Frequently, it can cause downtime while you're scaling down. There are cases where scale down works beautifully. If you're running Azure Kubernetes Service or Azure Container Apps or Azure App Services, basically if you have stateless web applications, then scale down is beautiful. You just stop some of those processes. Scale up is really scale out. You're adding more instances. So add more instances, take instances away. These are stateless applications, so if somebody gets moved over to a different app, different host of it, no big deal. But for databases are most certainly stateful, and as a result, scale down usually requires blocking. It could be 15 to 30 minutes for scale down to finish, during which time you're offline. People can't connect to your service. So if you're up a 24/7 shop and you're trying to take advantage of scale down of databases, your 24/7 suddenly becomes 23/7 if you have one scale up event and one scale down event over the course of a day. Not great. Also, you don't want to shift between tiers when you're scaling. So if you're already at the bottom tier of premium, you don't want to shift down to standard because some services may not allow that at all. Other services, that can be even worse of a downtime. So scale down, I don't think is usually a great solution. I think in a dev environment, or if you really do have one of those workloads that's very heavily staggered to a certain time of the year, you can probably get away with some of this. But for many services, and databases tend to be more expensive than app servers, I don't scale down databases. I don't think it makes sense. So here's the alternative. The alternative is what I call cloud native development. The idea is we're going to have a series of practices that fit better with a cloud development lifecycle. And let's talk about each one in turn. The first one is this concept of microservices. So I don't necessarily push people hard on microservices as such, and I think that you can go to the extreme. So I think of this more as maybe mini services. Microservices, in practice, these are small, independent, constrained services. They receive some information, they do one important thing, and they possibly output results. They probably queue up the next service in the line. You can run microservices on very small VMs. You can run them in containers and pack a whole bunch of microservices on the same hardware. So you have a Kubernetes cluster, and I may have dozens or hundreds of these microservices on several small VMs. The small VMs don't cost me very much money. Some of the services are running, other ones aren't. And so I can balance out the workload that way and essentially get closer to higher utilization on my virtual machines. I don't say you have to follow the microservice pattern exactly, where everything's got its own data storage and everything kind of lives and does exactly one thing. But think of it as a small part of the business process that can run independently. If you can break that down into something that is fairly independent, then you're in much better shape. Along with microservices, event-driven development is very important to the saving money. Microservices tend to receive information as events. So they're picking them up off of queues or off of lists, and they'll handle these requests as they're received. Typically, we're using these queues for message passing because the services can write out a message, it goes to the queue, service no longer thinks about it. The next service listens on the queue, and whenever this service is ready to pick up the message, it's available. Until it's ready, the message just stays on the queue, and no big deal. What this tells us is this service over here doesn't have to be on all the time. So for one service to communicate with another, we're now making this asynchronous where I can write to a queue. Queues are very cheap in Azure, and there are several queuing options that some of them are even less expensive than others, but all of them are inexpensive. So working with a queue, whether that's with Azure Queue Service or Event Grid or Event Hub, or there's a couple of others that you can use as well, but they're all good for specific tasks. And as a result, when that queue is holding your message, if the other service isn't running, it just stays there. And if you don't need that other service to be running 100% of the time, then you can shut it down for a little bit. And okay, every 5 minutes we spin it back up. It kind of takes over, or we spin up some more instances of it and pick messages off of the queue. So that way we can scale these services independently and possibly shut off some of the services periodically to allow other services to use those resources, the compute resources. Typically, when we're working on premises, we're having to think ahead 5 years. And so we bought that new hardware, it has to last us 5 years. And we tend to over allocate resources for on-prem VMs because it is difficult to scale them up once we've created them. It is easy for me to request, here's a SQL Server instance, I need 16 cores, I need 128 gigs of RAM. Relatively easy for me to request that. And then I get that. Maybe I have to negotiate a little bit with ops. Maybe we have to wait for the new hardware to come in. Maybe I have to tell them that I'm going to need that 6 months from now. And then when the new hardware refresh comes, I can get it. But the idea is it's not that difficult to get some level of support. But then if I come back a year later and say, hey, 128 gigs of RAM, I could really use 256 instead. They might say, I'm sorry, but we already committed all the RAM that's on that blade. We don't have any more RAM that we could give your VM. So it's harder to scale them in practice on premises than it is to build them initially, because it's all about a planning exercise. So as a result, what do we do on the VM allocation? We over allocate. I say I'm going to need 128 gigs of RAM, even if my databases for the first 3 years are 30 gigs of size. But I expect that in year 4, it's going to increase to 90. And in year 5, it'll be 150. And so I'm expecting that growth, and I have to anticipate that growth, and I have to plan ahead a little bit. So we may have servers that are doing like 10 or 20% CPU load, using less than half of their RAM. And that's inefficient from the perspective of immediate utilization. But knowing how difficult it is to expand, how difficult it is to scale it out, it makes sense. The incentives are for us to over predict so that we have less risk in the future. But if we're in the cloud, I want to push those CPU numbers much higher. I'm aiming for, on a SQL Server instance, on-prem, I'm aiming for like 20 to 30% CPU load, because that gives me a lot of room to grow. In a cloud, any CPU that you're not using, any CPU cycle that you don't use, you're still paying for. So I want to use more CPU. I want to push closer to, say, 65 or 75%. I don't want it to be 100% CPU, because then we start thrashing. The server's it's not responsive. It's using all of its compute time to arrange around tasks and just isn't working well under load. But we are paying for those unused resources. So if you do need to scale up the resources in a cloud environment, it is actually really easy to do so. It's, move the slider a little bit. So not a difficult task, something that we would want to have a little bit of control around, but basically, yeah, no big deal. Slide that slider, get our additional resources, and life is good. As a result, I recommend push those VMs, push those machines a lot harder in the cloud, scale them down from what you have on premises, because if you need to scale them up in the future, you can take that downtime and you can do it. It's 15 minutes one time. I don't recommend jump up, scale down, scale up, scale down, like on a daily basis or anything, but I am saying push it closer to the maximum of your existing setup. So if you've got 24 cores on premises, but you never hit more than 15% CPU, try 8 cores in an Azure VM, and you're going to save a lot of money over 20 cores, and you might be at 50% CPU utilization or 60%. And cool. And if you start pushing up to the 70, 80%, if you start getting concerned, all right, go from 8 cores to 12 cores. So it's still going to be cheaper, but you've made that one move, and you can make those incremental moves very easily. A lot easier than you can on premises, where we have to fight for declaring CPU core availability. I also recommend, we've got to hunt down technical debt. This is actually one of the nice things for developers when dealing with cloud services. On premises, it can be really difficult for the business side to let us fix technical debt. And the reason is, it's hard to quantify the benefit. If I go to a PM and I say, I want to get rid of tech debt, the first question is, what's the return on investment? How much money is it going to save the company or earn us? Or how can I sell this when the next best alternative is implement this feature? And I know, or I have a feeling of how much money this feature is going to make us. So your tech debt, it's hard to compete with something where there is money, there's a monetary value to it. But in the cloud, certain types of tech debt, really easy to classify. If I have services that are running that are poorly optimized, I have to use larger classes of machines, or more hours of compute time, and that is a direct monetary hit. So I can say, if we spend 20 hours optimizing these procedures, I can scale this VM down from 12 cores to 8 cores. And that's going to save you this many thousands of dollars per month. So now we have an ROI comparison. I have a direct measure of benefit of this is how much money that my tech debt solution will save the company. And so it's a lot easier to make that pitch. It's a lot easier to make that sale to the product manager versus on-prem, where the question of how much money is it going to save is a much more ephemeral answer. Because if I cut the CPU utilization by 30%, are we going to get rid of any CPU cores? No, we're going to keep those because, we need to grow into them. All right, so I didn't actually save costs. Well, I adjusted the rate of future growth. Okay, but how much did you adjust that rate of future growth? It's a murky answer. So this is much easier to sell when you have monthly bills. And I also recommend, I talked a bit about virtual machines here, but don't depend so much on virtual machines. The strategy in Azure and AWS is typically pretty expensive. It is usually cheaper to host all of those VMs locally, especially if you're dealing with larger companies. So if you've got a lot of virtual machines, if you've got a large data center, then it may be cheaper to host those VMs locally. The most price-effective services tend to be things that are platform as a service or serverless offerings, function as a service, things like blob storage or event hubs, app services, Azure Functions. These things tend to be cheaper than hosting your own VMs for everything. Now, one thing that I will point out, I have a blog post that I'm going to drop a link to in the chat here, and that is spot instances. So you can save a lot of money. This is the blog post, by the way. You can save a lot of money on spot instances. In practice, what a spot instance is saying is pretty simple. In an Azure data center, we have so many VMs. Maybe I have this many blades with this many cores, this much RAM, and it's all available. That hardware Microsoft has bought and paid for. They want to rent out all of that hardware. Well, they're not renting out all of it. So there's some stuff left over. And for the stuff that's left over, nobody's buying it at full price. So how about I sell at a smaller price? And that's where spot instance comes from. It comes from the concept of spot markets. So you're buying something for immediate delivery. I am buying utilization of your underused CPU and memory assets for some amount of time. I'm not buying it forever. I'm buying it for right now. And also with the assumption that, hey, if somebody comes in and pays full price, I can boot off the people who are running on spot instances. But until then, I can make some money, even if it's not all the money. And this is why we have spot pricing. Now, spot pricing, this was an example from a couple of years ago where we could see pay-as-you-go here for this particular VM was 90 cents per hour, whereas the spot price is 23.9 cents per hour. And so you'd say, well, you'd have to be a dummy to do anything but the spot price. Kind of. So the spot price is, like I mentioned, the price that you're paying because nobody else is willing to pay more. As soon as someone is willing to pay more, then they will kick you off. So if someone's willing to pay the pay-as-you-go price, or if they get a 3-year reservation, then they're going to get those assets. There's no kicking off the person who paid for pay-as-you-go or a 1-year reservation or a 3-year reservation, but there is kicking off the people who paid spot pricing. Where spot pricing works best is if you have services that can restart. Maybe you're running an off hours and you're doing some data analysis and you just need the heavy compute. You could run it in spot, and if your VM does get selected for eviction, you will get a warning. There's a message that pops up and it'll say, hey, your VM in 1 hour is going to be kicked off. So, or 5 minutes or some amount of time. They give you some amount of time to determine what it is that you want to save, how you want to spin this down nicely, and then they kill your server, your virtual machine. And the next person who paid more than you gets to take over. So spot instances are a really good way to save a lot of money if you have services that don't need to run 24/7. And if you have some easy ability to take them down and pick up where you left off later. I hope that you've got the story here that this is not the same thing as an on-premises solution. Your on-prem solution has a totally different look because the incentives are different, because the constraints are different. For on-prem, we are incentivized toward planning out big, planning out long, capitalizing the expenditures, depreciating and amortizing them, and having to think about what is your world going to look like 5 years from now. In a cloud environment, we're thinking much more of what do things look like at present. Also, in a cloud environment, we have to deal with network freakouts. We have to deal with oddities where, I can't reach the service for a minute. And then suddenly it comes back. So on-prem, we tend to ignore the network. We tend to pretend that networks are always reliable and always instant. In the cloud, we absolutely cannot pretend that. And so that also drives event-driven architecture, microservice architecture, some of these cloud services. It's another reason why we shift toward those. But basically, what I'm getting at is if you are moving from on-premises into the cloud, this is a good time to think about how you would reshape those services and plan that migration. This is not something you would want to take stuff on-prem and just move it into a cloud because you're paying more money, probably for worse results. So how do we get there from here? A few tips. First thing is start with smaller offerings. Start with things that are easier products to work with, that are simpler products to work with, and move those up first. They'll give you a pattern. They'll give you an idea of how to do this. Make sure you clean up technical debt because technical debt costs money. Remove external dependencies. Change the way you're accessing data, access through APIs. Be more asynchronous in how you perform your operations. Rigorously optimize code performance and database performance because every CPU cycle is extra money that you're paying. And minimize how much network bandwidth you need. Also, check out cloud architectures. Microsoft has a fantastic cloud architecture center. And I will drop a link to that here in chat. It is called the Azure Architecture Center. And I've brought it up right here. But they have literally hundreds of Azure architectures that you can, so 831 Azure architectures that you can use across a variety of different environments. So I might look at SQL Server related architectures, and there are diagrams, there are often explanations, multi-tier web application built for high availability and disaster recovery. So it tells you what are some of the services that you might use and how does this work. These architectures will probably look differently than what you would develop on premises for a similar problem. Also, take advantage of Microsoft's well-architected framework. The well-architected framework is a solution that Microsoft has put in place to help you organize your thoughts around your cloud setup. So if I open up this link, this is the Azure Well-Architected Framework, or WAF, and you can see the 5 pillars. The 5 pillars, one of them is cost optimization. So exactly what we're talking about in here. And if you drill into cost optimization, you'll get a lot of information. You'll get checklists of, hey, by the way, have you thought about these things? And it's literally checklists. You could print this out and check boxes. But have you thought about some of these items? Well, you can also go through the well-architected review assessments. And these assessments are detailed and powerful. Length of assessment, 60 minutes? No. Try 4 days. The assessments may take days to finish up. Like I'm going to go through data services, well-architected review. And we can see, I'm going to leave that open, but what we can see is, start the assessment. I'm going to have to sign in. Watch me sign into Azure. All right, start my assessment. What workload do we want to evaluate? And I can look at data services. Which data service? I can say, I have a SQL Server on a VM. And then we'll ask, what pillars do you want to evaluate? So I could go through all 5 of these. And 40 pages, 3 of 40 pages. So if I go through the list, there are some of these questions that as a DBA, I might be able to answer off the top of my head. But for some of them, I may need to go talk to my networking team. I may need to talk to security teams. I may need to talk to finance teams. I might need to talk to application development teams. I may need to talk to a variety of different teams at different levels in the organization to get all of the answers in here. And these are not just simple A, B, or C, but how are you monitoring your SQL Server deployments and environments? So do you have alerting and monitoring in place? Yeah, sure, I do. Are you correlating events between different application tiers? And there are there's a follow-up explanation of this. Are you parsing logs for errors? Are you tracking deployment metrics? How are you doing on deployments? What are you doing for deployments? And so these can lead to discussions that lead to hours of in-depth analysis with the organization before you can check the box or say, no, we don't check the box. And at the end, what you get is a set of results. And these overall results kind of put you in a tier of how are you doing relative to your peers and in each of these categories. So in this case, this is a cloud adoption journey assessment. And so how are you doing in terms of your strategy? Okay. Your plan is okay. Are you ready for the adoption? No. And etc. As well as recommended next steps and ways to improve your result. So if you drill into one of these recommended actions, they'll give you, sometimes they will give you, this is the actual script to run to do this task. There we go. So it'll give you this idea of, here are the very specific things that you can do to improve your outcome, improve your results. And some of that may be, select this and it will resize your VM and will save you money right off the bat. So those are the WAF assessments. Quite detailed, but very useful. Highly recommend them. As far as this goes, I am not going to walk through the estimate. I'll save that. If you're interested in how I go through the method for it, I will give you a link to the slides at the end, so you can check that out. I do want to spend a few minutes on budgeting and alerting before we wrap up, though. So budgets. Budgets are something that we can create in the normal world. Budgets let us know when we reach a certain level of spend, or they give us a cap of how much we're allowed to spend. So I set a budget for how much I want to spend on groceries, how much I want to spend on fuel, how much I want to spend on natural gas, water, electricity, etc. And then add up all of those budgets, and I get to my entire budget. I figure out how much money I make over the course of a month. How am I doing as a result of this? With Azure budgets, they're not stopping you. They're instead alerting you when you reach spend levels. So in that cost management blade, you can select the budgets option from cost management section and add a new budget. This budget, I have one here. It's a fairly simple budget that basically says, if I spend $101, I want to receive an alert. And so I'll get that alert if I spend $101. So we could see that in July and August, I would have received the alert. In September, October, maybe I'd receive the alert. September, no, did not receive the alert. And once I've built out that budget, I can then create a cost alert. So I can send a message when I'm at the budget or close to the budget. So in this case, I could send an email to the accounting team when we hit 85% of the budget. And if they're getting that 85% alert, halfway through the month, we know that there's a problem. And hey, dev teams, what is going on? Because you're going to blow past the budget. You might set that alert lower so that you receive it, say, a 50%. Half of my budget, when do I get it? Do I get it about halfway point of the month, 2/3 of the way through? Do I get it on the first day because someone spun up a really expensive service and forgot about it? And this will help keep you from getting that $200,000 monthly bill that's totally unexpected. So these cost alerts, though, they will not prevent spending money. All they'll do is alert you as you're spending money. I still recommend setting those up. I still recommend putting them in place so that you have an idea of how much it's costing you on a regular basis. Unfortunately, it is not a spending limit. Now, if you have an account that uses Azure credits, there is a spending limit by default. So in this case, my Visual Studio Enterprise account has a credit limit, $150 in credits, and I have highlighted the alert that says I've got $67 in credits remaining. If I need to go above that number, let's say that I messed up and it's only the 5th day of the month and I'm almost done with those credits, I can associate the account with a credit card or some other way of payment, some other payment mechanism, and can, for the month or forever, allow overages to be charged to my card. Otherwise, if I hit that spending limit for credits, it turns off all of my services until the next billing period. So if I hit that limit on the 29th of the month and I don't have a credit card or something, all my SQL databases are shutting down. All of my other stuff is shutting down. If I'm relying on that, too bad. Unfortunately, I cannot set custom spending limits on regular subscriptions. So if I have a regular subscription that is not credits based, I can't say I want to spend no more than $10,000 in dev for a month. All I can do is set alerts and yell at people. We can, however, perform some level of tagging and chargeback within organizations. So for a large company, or if you're dealing with multiple clients, you might perform chargeback for your internal accounting or even external accounting with those clients. And the easiest way to do this is that you would tag the individual resource groups and resources with whatever department or whatever customer is associated with them. And then in Azure Cost Management, you can create reports based off of those tags. Performing a chargeback within a resource, like let's say you've got an Azure SQL database and you've got 20 customers. There's no way for you to say what percentage of DTU load is associated with this customer using just tags. You might be able to understand what queries people are running, understand how much data one customer is using versus another customer, and maybe with a lot of effort can piece that together. But it's a challenge. It's a real challenge that I don't think there's a good answer for in Azure or even on-prem SQL Server. I don't have a good way of doing chargeback. So something to keep in mind, unless you have separate instances for different customers, in which case, yeah, you could do chargeback that way. But, if you're talking multi-client, maybe multiple databases, one per client, real tough to say how much of the server's resources did this customer use. So that's going to wrap us up. Over the course of this talk, what we did was looked at the billing model for the cloud, figured out a little bit about this OpEx versus CapEx debate. Hopefully I clarified things a tiny bit, or at least gave you some understanding of why it is that accounting people throw down over this. We looked at the Azure pricing calculator. Hopefully I demystified it a little bit. We looked at some strategies to save money in the cloud. And if you do want to get more information, if you want to get this talk, if you would like to get links to additional resources, go to csmore.info/on/wallet. If you have any questions afterwards, please do feel free to reach out to me. My email address is right here. I will also post my Twitter handle. And with that, happy to take any questions that anyone's got. Hey, thank you, Mark. Also, while I'm waiting for questions, I do want to say thank you, everybody. Let me switch to the big cam. That way I'm 40% more personable. Thank you, everybody, for sticking around with us. I did actually get an email during this from the speaker, so we'll sort that out. Maybe we'll try to get her back for later on, and then we'll get that original talk. But thank you for sticking around for this one. Appreciate you being here with us throughout the course of the year. Do you know how complex the billing is for Fabric? Yes. The answer is complex. So it's here. Let me bring up this article from Razorrad. So Razor's got a blog post. Razor's also got a video, and I'm going to drop a link to that in here. Basically, for Fabric, you are paying for capacity. So F64 is what I would consider the starting point for Fabric pricing. That is because it is the equivalent of a Power BI Premium P1 SKU. So it's 8 Power BI vCores or 64 capacity units in Fabric. Monthly cost, $8,400. For P1 Power BI Premium, this is like $5,000. So there is additional overhead. Now, the good news of Fabric is that within that $8,400 a month, there really aren't many, if any, additional costs. So this is software as a service pricing versus platform as a service or infrastructure as a service pricing. So they're basically saying it's all in. So storage costs are not included in capacity licensing. You do need to pay for that separately. This is the exception. You're paying 2.3 cents per gigabyte per month for standard storage. And there may be networking costs as well, but there is no user-based licensing for Fabric. So basically you're saying, I've got my premium capacity of $8,400, and now anybody in my company is able to use that premium capacity. If you have Power BI Pro licensing, let me double check that. Yeah, you can only use Power BI objects if you have the dedicated capacity or have a Pro or PPU account, premium per user. So it is a little bit more complicated, especially when you're trying to sort it out like with relation to other services, but that's the general billing model. Okay, question number 1. You mentioned that some services can differ in price by region. I'll assume that choosing a faraway region will slow down your processing time. It could potentially, yes. You figure there is going to be some level of network bandwidth cost, like latency, that will happen if you're communicating with Australia versus next door. So there will be latency as a result of that. And let me see if I can pull up one of those links for pricing by region, because there are some services. Yeah, actually, this is a good one. Okay, AzurePrice.net. I have looked at this one before, and here's what we're talking about. This is really, I increased the size so that you would stick to the full size. All right. If you look at the chart, Central India, North Central US, those are the cheapest regions. The most expensive ones: Brazil Southeast, Switzerland West, South Africa West. So for some of these regions, they're significantly more expensive than others. And this is average price per VM per hour, based on however they did the calculations. So we could see East US is $1.26. East US 2 is actually more expensive. West US is a little more expensive than that. But North Central US, which I think is Chicago, is the least expensive. And West US 3 and West US 2 are both cheaper than West US. Some of this is Microsoft wanting to shift people between regions. So they'll make the region that's a little older, that has more users on it, they'll make it a little bit more expensive. And the VM comparisons, you can see also per VM type, what is the best region. So let me switch myself back to the top here. Like if I'm using B1, let me look in the B1 series, because that's a cheap burstable. Here we go. It's a burstable 12 vCPUs. Actually, West US 3 is the cheapest, and I can compare prices for it. So here's my my West US 3 price is 49.9 cents. East US is the same. East US 2 is the same. So I kind of get some idea, but then we get some more expensive ones as well. So you can see this is not always true for every VM type in every case. Sometimes this will be less expensive in West US, or sometimes you go to Central India. And yeah, there can be a huge difference. Like here, this B2AL2VS, 2 CPUs using AMD cores with low memory and premium storage. It's a very cheap VM. It's 4.68 cents. But in India West, it is the cheapest, versus some of the other regions where you might be paying twice as much for that VM. So there can be a big difference. Now, how can you test or figure out how much slower things will go if you pick a region that's further away? I'd say the answer to that, you can spin up the resource and you could run ping testing, so you could figure out latency. You may have to do load testing. So if you have a SQL Server instance that's in Central India and an application that's in East US, then you may have to run a load test on that. Now, one warning is you are paying for inter-region networking. So if you have your app in East US and you have your database in Central India, you will pay for the network traffic that crosses. It is a better idea to co-locate your resources. So if your database is in Central India and your app is in Central India, you're not paying for network communication between those two. You pay for network communication that goes out to the end client. That tends to be very cheap. But apps, especially chatty applications that pull a lot of data from the database, you might be paying more money than you're saving on the VMs by hosting them in different regions. So that's a counter consideration. It's a reason that you might say, I would rather, yes, spend the extra 5% to have everything be in East US versus some of it in North Central, some of it in East. But as you go through, definitely load testing. Try out common patterns that you have seen in your environment. If you're, say, loading a warehouse, see how long it would take to load that warehouse from if your instance is in Europe versus in Asia versus in the US. Question 2, what do you mean by lift and shift? Lift and shift is the metaphor is you're taking your VMs that are on premises, you just put them in a box, take that box, move it into Azure, drop the box in, open the VMs, everything's there. The less metaphoric explanation is this is where I would copy my virtual machines. And if you have a new version of VMware, if you're using ESX, if you're using a new version of ESX, you can simply deploy that virtual machine into Azure or into AWS without making any other changes to it. It is a snapshot of the machine that is pushed up into that cloud service. So yeah, it'd be moving an on-prem database into a cloud. So if I had a SQL Server instance, instead of using Azure SQL Database or a SQL Managed Instance or trying out anything different, I would install SQL Server in my cloud instance, restore from backups, and just run it in the cloud as though it were on-prem. All right. If there are any other questions, I'm happy to take them. Otherwise, we are near the end of the year. This will be the final meeting for the Triangle Area SQL Server User Group in the year 2023. We'll come back in 2024. I mentioned yesterday on Shop Talk, we might have Shop Talk on the 1st. I don't know yet. But if not, we'll have it on the 15th. We will have our Advanced DBA group, our main meeting, and our business intelligence and data science meetings all happening throughout the course of the year. Easiest way to stay up to date on what's happening is to join our meetup, meetup.com/TriPass. We post everything there. And until we see each other in the new year, everyone take care. And, like Elaine said, happy holidays, Merry Christmas. Hanukkah is already passed, but, hopefully Chag Sameach if you were there. But until we see each other, take care. What's the YouTube link to this presentation? Let me give you the link to the YouTube channel. And I will, that will probably be the easiest route. So the YouTube channel, I've got a playlist that I need to find. And that particular playlist is for all Triangle Area SQL Server User Group meetings outside of Shop Talk. And if I get the link to it, I gotta get shareable link. I think that's what I needed to do. Yep, here it is. So that is the link. That'll give you everything that we've got up on the channel. There are a good 105 videos currently up there over the course of the past several years. And there's another playlist for Shop Talk. If you really want to go back and watch those older episodes of it, they are there. So I will probably post this video later on this week. I'll post Shop Talk probably tomorrow or Thursday. And I'll have both of those videos up, and then they'll be there. So yeah, until we see each other again, everyone, take care.